Morning everyone, my name is D. Nandasunil. Today I am explaining about what is minimum spanning tree. Explain minimum spanning tree algorithm with example. Introduction to minimum spanning tree. A minimum spanning tree is shortly denoted as MST. Connects all vertical in a graph that minimum total edges of weight. Like it connects the edges of the weight in the graph. Here we can see the graphs. Spanning tree costs 13. Here we can see the least count 13 the only diagram covers in the edges, and the minimum spanning tree costs 7. Here also the spanning tree touches the edges only. It is used to optimize the network design as a telecommunication and a transportation. It is used likely we can use this in the telecommunication and transport system to find the best routes in the day-to-day lives. Understanding the MST helps in solving problems involving in the most efficient way to connect the points. It's nothing but the connecting points, which is useful or easy to makes the way easy. What is spamming tree? A spamming tree is a subset of graph that includes the vertical with no circles. There is no circles in the spamming tree. Only the verticals and the edges are the connected. So it is called the spamming tree. It connects all nodes with the minimum number of edges, which is one less than the total number of vertices. One less than total number of verticals is in the total number of edges or verticals. The number of connections is less than the total number of edges. Every graph has last one spamming tree, but not all the minimum in the term weight. What makes the minimum spanning tree? A minimum spanning tree, MST is spanning tree with the smallest possible sum of edges. Like here we can see the diagram. There is a SACBT. Here if we want to find the small spanning tree with the smallest possible sum, then we can use the minimum spanning tree. Ensure all vertices and connected with the least count of distance. Here we can find the least count to reach our destination. It's useful in minimum spanning tree. There can be minimum spanning trees for the same graph in equal have ensure all verticals are connected with the least count of distance. Here we can see the verticals are connected. We want to find the least count by the connecting of the verticals. There can be multiple MSTs for the same graph if the edges are equal weights. There is a one type in least count crucial algorithm overview. We can dive into the crucial algorithm overview. Crucial algorithm sort all edges by the increasing weights and adds them one by one. It's like sort all the edges by the increasing the weights and add them one by one. It only adds edges that do not form a cycle with the already included edges. In Crucial's algorithm overview, we do not find the loops like circles, which can contains loops. It can add edges that not perform a cycle with the already included edges. The process continues until the vertices are connected from forming the MST. Here we can find the steps. Sort the edges in the ascending order in weights, and the second step is pick the edges and the least weight. Check if including this edge spanning tree will be cycle is yes. Then ignore it. Know them, add it to the spanning tree. 3. The third step is repeat the step 2 until the spanning tree has V1 edges. V is equals to verticals in graph. Edges 0 to 1, no cycle. Here we can see the edge 0 to 1, there is no cycle formed, and 1 to 2, there is no circuit formed. But if we can connect the 2 to 0, the loop is formed. So So we do not do the step in Crucial's algorithm. It's not needed. Crucial algorithm extends the consider the graph with the A, B, C, D, the edges of the various weights. Uh, first so edges weight, then we select the smallest edge, avoiding cycles, continually adding edges until the vertices are connected, resulting the MST. The prism algorithm overviews. Prism algorithm is a one type of MSTs. Prism algorithm starts with the arbitrary vertex and grows the MSTs by adding the smallest edges connecting to the new vertices. It maintains a priority queue of edges to efficiently select the next minimal edge. The process repeats until all vertices are including in the spanning tree. Like prism algorithm example, there is some examples in prism algorithm. Starting from the vertex, select the smallest edge connecting 8 other vertices. Add the next smallest edge that connects the current tree to the new vertex, continuing until the all vertices are incorporated into the MSTs. Comparing Crucial algorithm and Prism's algorithm. Crucial algorithm is most efficient in the sparing graphs, while Prisms works well with dense graphs. Crucial sorts the edges initially, whereas Prism grows the trees incrementally. Both algorithms guaranteed finding an MST if the graph edge weights are distance. Here we can see the difference between Crucial algorithm and Prism algorithm. Real world applications of MSTs are used to design efficient network cabling in the communication systems. Minimum spanning tree is used for the communication system. We already discussed before. They help optimize road and railway networks to minimize constructions and cost. MSTs algorithm are also supplied in the clustering, image segmentation and circuit design terms. Summary of the conclusion: a minimum spanning tree is selected all vertices with a minimum total edges of weight. Crucials and Prism's algorithm are most common methods in the minimum spanning trees. Understanding the minimum spanning tree is their algorithm is essential for solving many optimization problems. Here we can see the real world example of the minimum spanning tree. Thank you for giving this opportunity.